Okay, hello, welcome back, people of planet Earth. It's Francis again. I've been having a week off doing this because I was tired, but also my 7-year-old daughter and her mum were ill with coronavirus, and I was a bit stressed about that. They're actually recovered now. They reclused for 10 days. They're now negative, so I think they're back to health now. So my daughter wasn't really affected, but my mum was in bed a bit. But anyway, I thought I'd go over this paper on adenovirus just to elaborate some of the detail which I started on last time. This is a diagrammatic image of adenovirus. That's the capsid, that's the DNA inside, and these are the spike proteins. The hexons, the individual proteins in the capsid, and at the base of each red spike is a penton protein. Okay, so this is the overall adenovirus structure, and it's 80 to 90 nanometers across. Okay, well that's 80 to 90 nanometers, sorry. You can see the dimensions there. The actual capsid is probably about 50-60 nanometers across. So that gives you an idea. And if I then go to the actual, this is the paper, you remember? I thought I wanted to highlight a little bit on these yellow ones, protein 3A, okay? And also the green hexons over not there, wrong image, excuse the camera rotating. These actual clusters within the capsid's coat, okay? And the pentons are little protein clusters which sit on each vertex of the protein. You see each of the faces here. There's a face, triangular face there, triangular face there, triangular face there. There's 12 faces, I think. 12, is that right? 12? Yeah, there's 12 how many faces are there? Okay, well, each capsid is 720 hexons. And I'll write this out a bit later. Each capsid is 720 hexons, arranged as 240 trimers. Each face is 12 trimers. So yeah, there's 720 hexon protein clusters in total, 240 trimers. They're clustered in 240 trimers, and 12 trimers per face. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Approximately 12 per face. The actual proteins in the capsid, each one is 900 amino acids in all adenoviruses. The proteins are folded into 2 8-stranded barrels, beta barrels, which held apart by a small beta sheet. I'll try to show this. I can't draw it here. I'll show it in another video. It's too difficult to draw here. But basically, if I scroll down, okay, you've got these, okay. That's a hexon trimer, okay. The blue shade is one of the monomers, okay. The other grey shading is the other 2 monomers, okay. As I said, there are 720 hexons. The blue B here is a pentamer. That's the vertex of each of where all the faces meet. This is 5 subunits. 2 of them are highlighted, 1, 2, 3, 4, and then there's a lighter one behind there. So there's 1, 2, 3, 4, 5. Okay. That light one there you can see is one of them, I think. 1, 2, 3, 4, 5. okay? And there's what you call an RDG loop shown here. RDG stands for arginine, glycine, aspartate amino acids. The 3 is this is a structure of, I will try to make that bigger so you can see it more clearly. You can't see anything in this. Okay, excuse me. And you have okay, the I'm just giving you a bit of detail about the actual molecular structure of virus here. So here what you have is, this is where the spike protein attaches to the actual capsid. You got, this is a diagram of it. So you got, that's a pentagon, 5-fold symmetry, and within there's a triangle which is 3-fold symmetry. So you've got the fiber, which is these colored domains, are bound to the penton base, which is the faint behind, okay? The fiber has a 3-fold symmetry, 1, 1, 2, 3, okay? And it's, in this diagram here, it shows how it's shifted relative to the penton base. So this is 3-fold symmetry, and the penton base protein is 5-fold. So you've got 1, 2, 3, 4, 5 faces, okay? So this is the protein, and you can see within that the beta sheets, which are those parallel lines, okay? I don't know if you can see that very easily. We've got, I will try to, you got these parallel lines here, those are called beta sheets, okay? Parallel lines here, okay? So you got parallel lines here, here, and here, okay? Yeah, so you got, so you got 1 side, 2 side, 3 side, 4 side, and 5 side. That's 5-fold symmetry, and there's a 3-fold symmetry. So that's the fiber protein sticking onto the base of the penton, which is on the capsid. Okay. Yeah. Now RDG is 3 amino acids. Okay. Arginine, glycine, aspartate. I'll go into that in another video, running out of time a bit in this. This is quite complex. I'm giving you some of the more important details. There is a lot of complicated detail which is far too technical for a short video for beginners, but I'm giving you some of the main points of it, okay? This is part of protein 3, which is these yellow colored proteins within the capsid, okay? That's inside the capsid, okay? The yellow proteins. This was our, so this is a protein 3, and it's you got, it's 585 amino acids and has alpha helices. That's these spirals, okay, these are called alpha helices, joining 2 globular domains, which I think is this region and this region, okay? It's a little difficult to see in this what's going on, but I'm just giving you an idea what's going on, of just the structure. The alpha helix is joining 2 larger sections, and this GOS glue refers to, it's called glue because it's joining the 2 different sections together, okay? I think it's this section here, okay? And this pentamer thing represents, this whole thing is in fact got 5-fold symmetry, okay? Which is not obvious from this, but there's obviously got a 5-fold symmetry going on. That's why there's a pentamer here, and there's a glue thing here and joining the domains together, and these are alpha helices, okay? An alpha helix is basically a spiral, like the structure of our DNA is a helix as well. That's a good, yeah, that's the beta sheets. And That's more, you can see some sheet in here. You can see the parallel strips there, like ribbons. Okay, and a bit of helix, but a lot of it's very disordered in this. Okay, see you next time. Please subscribe if you like these, and like them as well. It will help my videos. Subscribe and pass them on. I'm enjoying making them. I did say I was going to talk about virus molecular structures, which is why I'm trying to show you the molecular structures. Anyway, subscribe, it will help my channel, and like them please. And please give me any feedback as well, comments or questions you have. I will try to answer them. And if you have suggestions for other videos, please give them. Although remember, my expertise is chemistry and biochemistry. Thank you, bye.